Okay, this lesson's on double angle formula. Double angle formula shows a relationship between an original angle and twice its angle. Okay, so 30 degrees to 60 degrees, or 7 degrees to 14 degrees. There's a relationship that's been proven over time that holds. And there's different ones for sine and cos. So sine of double the angle is equal to 2 times sine the original angle, cos the original angle. So if you're to take, let's say, 30 degrees, A equal to 30 degrees. So I have sine 30 degrees, cos 30 degrees. Take that, and there's a relationship with sine and double it, which is 60 degrees. And the relationship is you multiply those two together, sine 30 degrees, cos 30 degrees, times it by 2, you would actually get sine, the value of sine 60 degrees. All right, and that has been proven. I can demonstrate that sine 30 degrees is 1/2. Cos 30 degrees is root 3 over 2, and you multiply that by 2, you're going to simply get root 3 over 2 is what, and that is also what sine 60 degrees is. So again, it holds true. Cos double angle, you have your double angle and your original angles, and there's actually 3 different relationships that will hold true for doing that. Again, you can test it out with putting in 30 degrees for your A's, and you find out what cos 60 degrees is equal to, and using either one of these 3 formulas. So there's 1 formula, double angle formula for sine, 3 double angle formulas for cos, and we can use them to help answer some questions. Okay, let's take cos angle A. So we don't know what angle A is. Who cares? But it's equal to 2/3. Find cos what cos double angle A is. Now there are 3 versions of the cos double angle formula. We're only given what cos was. A lot of these require cos and sine, except for the one right here, the second one, the middle one. It only requires cos original angle. So let's use that one. So cos double angle equals 2 cos squared A minus 1. Now we know what cos A is equal to. It's equal to 2/3. So I have 2/3 for cos A, but that's 2/3 squared, cos squared, minus 1. 2, that squared to become 4 over 9, square both the top and the bottom, minus 1. That would give me 8 over 9 minus 9 over 9, which would give me 1 over 9, negative 1 over 9, as an answer. Okay? So again, you're just going to be working with your fractions a little bit. If cos angle A equals that and sine angle A equals that, find sine double angle. Now there's only one sine double angle formula. Now you know what your sine and your cos A's are, so put them in. Sine A was negative 3 over 5, cos A was 4 over 5. And just simply work with it. That's negative 12 times 2 would be negative 24 over 5, and that is sine whatever my double angle is. Who knows? Who cares? You don't know what the original angle is, so you don't know what your double angle is, but you know what it's equal to. Okay? And part C here, if sine x equals 12 over 13, where the angle x is between 90 degrees and 180, find the value of sine double angle x without a calculator. The part that's missing right here is cos x, because my sine double angle formula requires both components to be able to complete it. I know what sine x is, I do not know what cos x is. But I can figure it out because if I do a little right angle triangle, put down angle x, okay, sine is opposite over hypotenuse. Well, sine, that would be 12 over 13, opposite over hypotenuse. And you just have to figure out what your adjacent is. Well, that's the Pythagorean theorem. Let's call this, let's call it A for adjacent. Okay, so I have 169. Equals 144, sorry, plus a squared, so that'd be 25 equals a squared, and 5 would equal a. So cos x would equal 5. So a equals 5, so cos is 5 over 13. That's my adjacent. Adjacent was 5, and my hypotenuse is 13. Now, but it said it's between 90 degrees and 180. C-A-S-T. 90 degrees and 180 is in the S quadrant. Sine was positive, that makes sense. But cos in that quadrant is negative. So I need to make sure I put negative 5 over 13. So I have my two values now. I have 2, and I have 12 over 13 for my sine x, and my cos x was negative 5 over 13. Put them in. I'm going to get negative 120 over 13 as an answer for sine 2x. Okay? Oh, sorry, over 169. Bad math. Multiply 13 times 13, 169. Okay, so before you can figure out what the missing one was, use a right angle triangle, set up your opposite and hypotenuse, and figure out your adjacent. Use the Pythagorean theorem. The last ones here are just doing some simplifying. Now, with these, you're going to be given ones that kind of look a little weird, and you're going to you got to make it look like one of the original double angle formulas. Now, this one clearly looks sort of like the sine 2a equals 2 sine a cos a, like the sine double angle formula, but it's not. You have a 6 instead of a 2. So that means that is 3 times your double angle formula. So it's 3 times the sine 2a. Now, same as this one right here. 2 cos 3x sine 3x. That looks very similar to the 2 sine a cos a. That's the closest one it looks to compared to the other double angle formulas. You got the 2 in front, you got the sine, you got the cos multiplying each other. The difference is you don't have, instead of a, you got these 3 x's in here. Okay? And it also is saying, sorry, that is sine 2a equals. It's also, you have it backwards. That's okay. Multiplying the order does not matter. So I know that instead of a, I have 3x. So instead of 2a, maybe 6x. So this is actually really equal to sine 6x when I simplify it down. Okay? Your angle A is a 3x. So if I want to put it into a double angle formula, it would be actually a 6x that's in there. Okay, so this is a short lesson on the double angle formulas. There is one double angle formula for sine, and there are 3 for cosine. It's just a matter of knowing which one to use when. Thank you very much.